Hello students. In last class we have studied about the classification of carbohydrates. In that we have studied the monosaccharides, oligosaccharides and polysaccharides. In today's class we are going to study about the monosaccharides. In this we are going to study the two examples, that is one is glucose and another one is fructose. Let us start with glucose. I hope everybody has seen the powder which is uh, which you are getting in the market as Glucon-D. Have you seen how it is? It is white crystalline powder. And have you tasted it? It is sweet in taste because it contains glucose. So saccharides are nothing but sweet to taste that we have already seen in last class. Now, why it is sweet? Because it is found in sweet fruits. So let us start with glucose. Occurs in nature in free and combined form. It is present in sweet fruits and honey. Ripe grapes contain large amount of glucose. Hence, it is also known as grape sugar. It is the most important simple carbohydrate in human metabolism. It is an aldohexose and also known as dextrose. What is aldohexose? What is the word aldohexose? Aldo stands for presence of aldehyde functional group and hexose stands for 6 carbon atoms. You have seen the molecular formula of glucose, which is shown in the bracket as C6H12O6. Then dextrose means the rotation of plane polarized light towards the right hand side. This is about the glucose. Now we are going to study about its composition, which is also called as elucidation. So elucidation of glucose structure. Now how the question can be asked on this part is, any one proof is asked for 1 or 2 marks with reaction. Molecular formula of glucose was found to be C6H12O6. This is by molecular mass determination method. Presence of straight chain of 6 carbon atoms. See, glucose contains 6 carbon atoms, but how they are present? They are present in straight chain. So this can be proved by using the reaction with HI. Now, this is the formula of glucose. CHO, CHOH 4 times, then CH2OH. The reaction is carried out by heating the glucose with HI in presence of red phosphorus. So it forms N-hexane, that is straight chain of 6 carbon atoms. Now what is hexane? That we have already studied in last year. N stands for normal, that is straight chain. Next one, the presence of carbonyl group. Carbonyl group is present in aldehyde as well as in ketone. So, how it can be proved? Reaction with hydroxyl amine, that is NH2OH. So here glucose is treated with NH2OH. Now NH2OH is rearranged as H2NOH. So H2 from hydroxylamine reacts with O from the aldehyde, that is CHO, forming water. So remaining part is what? N and OH. Now that N and OH is replaced in the place of oxygen. So this is how the product form is aldoxime, that is CH double bond N OH. Then CHOH 4 times CH2OH as it is. Next proof is for presence of carbonyl group as aldehyde. Reaction with bromine water, which is also called as oxidation reaction. So glucose on oxidation with bromine water, it gives gluconic acid, that is CHO group is converted into COOH. This shows the presence of carbonyl group as aldehyde, that is glucose contains aldehyde functional group. Now, this type of reactions can be asked for 1 mark. That is, for example, give the evidence for the presence of carbonyl group as aldehyde, or give the evidence for the presence of carbonyl group, etc. And such question is asked in March 2020 exam for 2 marks. One is presence of carbonyl group and second one as straight chain of 6 carbon atoms. Next one is presence of 5OH group, that is hydroxyl group. Now before going to this reaction, I will tell you one thing. If any one carbon atom is having 2 OH group on the same carbon atom or on that particular carbon atom, then always it is unstable and it loses the water molecule. That is called as dehydration. The condition is if the 2 OH groups are present on the same carbon atom. Now, let us start with the reaction. That is reaction with acetic anhydride, CH3CO twice O. Glucose, 1 molecule of glucose requires 5 molecules of acetic anhydride, which shows that it consists of 5 OH group. This is called as glucose pentaacetate. Where the reaction is taking place? The reaction takes place only at OH group. So CHOH consists of 4 OH groups and CH2OH consists of 1 OH group. So total 5 pentaacetate are formed. Now this product form does not undergo dehydration, means there is no loss of water molecule, which shows all 5 OH groups are attached to 5 different carbon atoms, not on the same carbon atom. So from all these evidences, the structure obtained by the scientist Fischer, and this is called as Fischer structure of glucose, which is also called as open chain structure of glucose. Now, what is written here? Glucose is correctly named as D plus glucose. Now, D stands for configuration with respect to glyceraldehyde. Glyceraldehyde is one organic compound with which the glucose structure is compared. Now, plus shows dextrorotatory, means it rotates the polarized light towards the right hand side. Hence, it is called as dextrorotatory. Now, if you want the detailed information about this, you can refer the page number 406 and 407 in government textbook. How the structure is shown? Let us come left hand side. First carbon atom, it is having CHO, that is glucose consists of straight chain of 6 carbon atoms. So 6 carbon atoms are shown here, one by one in straight line. Then it consists of CO group, that is carbonyl group, which is shown here, C double bond O. Now this carbonyl group is present in the form of aldehyde. So it is CHO. Now next one, it consists of 5 OH group. So 1, 2, 3, 4 and 5. This is how all the evidences are shown in one structure, which is called as D-glucose, that is open chain structure of glucose. CHO group is always written at the terminal, that is at the end. Though many reactions are proved by this open chain structure, but some of the reactions could not be explained by the open chain structure of glucose. Practically, it is found that there are some reactions are not shown by the glucose, and for that, it is considered that the aldehyde group and one of the hydroxyl group may be rearranged in the form of the ring structure, and this ring structure is called as hemiacetal structure. So how the ring is formed? It was found that glucose forms a six-membered ring in which OH at C5, that is carbon number 5, is involved in ring formation. Now, which one more carbon atom is linked? So, first carbon atom, and that is CHO, and the fifth carbon atom, both are linked in the ring formation. This explains the absence of CHO group and also the existence of glucose in two forms. These two cyclic forms exist in equilibrium with open chain structure. Let us see how these cyclic structures are formed. Just see the middle structure, that is open chain structure of glucose. The first carbon atom is CHO. The first carbon atom is CHO. The second CHOH. Third CHOH. Fourth CHOH. Fifth CHOH. And last one is CH2OH. There are total 5 hydroxyl group, 1, 2, 3, 4 and 5. Now, just see in this structure, the third carbon atom which is attached to OH group, that OH group is always on the left hand side. Remaining all OH groups are on the right hand side when we draw the straight line structure. Now, the OH group which is attached to fifth carbon atom along with its lone pair goes towards the first carbon atom, and the double bond between C and O gets shifted towards the O. Here O forms negatively charged, that is O is having the pair of electron and it becomes free. So this O is linked between first carbon atom and the fifth carbon atom, which you can find out in the beside structure. Now this OH can be attached to the right hand side of the first carbon atom or the left hand side of the first carbon atom. Now just turn to the left hand side structure. If the OH group is attached to the first carbon atom on the right hand side, then we call it as alpha D glucose. Now here one more word is there, pyranose, because it forms a six-membered ring structure. In right hand side structure now, what you can observe, this OH group is on left hand side. So this is called as beta D glucopyranose. If you see here, these two structures are very much similar, only they differ in first carbon atom. That is the position of OH group on the first carbon atom. Remaining all carbon atoms are having the same groups on the same side or same atoms on the same side. Now, what are these two compounds then, or what are these two pair? These are called as anomers. That is a pair of optical isomers which differ in configuration, that is attachment, only around C1 atom, that is at the first carbon atom, are called anomers. Example, alpha and beta glucopyranose. Now what is pyranose, that we will see in next slide. I hope you understood how the attachment takes place from fifth carbon atom to the first carbon atom. This type of linkage with oxygen between the two carbon atoms is called as glycosidic linkage. Now, this type of structure is called as Haworth structure. So, to draw this Haworth structure of glucose, what we should do first? We should draw the hexagonal ring, that is this ring. 6, just like benzene. One of the carbon atom from the benzene ring is replaced by O. Then you have to draw the vertical lines, that is 1, 2, then 3, 4, 5th and 6th carbon atom will come here. This is how two structures are drawn. Now one is shown as alpha D and beta D. Now here one note is given. To draw these structures, all LHS groups or atoms are written above. Above means you should write it here, like this. And all RHS group or atoms are written down, that is with this. Down the plane of hexagonal ring, that is called as pyranose ring. Just see which are the right hand side groups and left hand side groups. These are all called as left hand side groups, which are written above the plane of the hexagonal ring, and these are called as right hand side group or atoms. Oxygen is linked in hexagonal ring. So here the structures are shown in detail, that is Haworth structure of alpha and beta glucose. The basic structure is pyran ring, that is 6-membered ring with one of the oxygen. One carbon atom is replaced with oxygen. Now next, alpha D glucopyranose. I told you why it is called as pyranose, because it forms a 6-membered ring which is similar to the pyran, and hence it is called as pyranose. Now here each and every carbon atom is numbered. This is number 1, 2, 3, 4, 5 and 6th. Sixth one is CH2OH. Now while drawing this, Always the numbering is to be done from the clockwise, that is after O the first carbon atom, second, third, fourth, fifth and sixth. Always the sixth carbon atom should be written on the top, that is above the plane of the hexagonal ring. Now, how to identify alpha D glucopyranose? If the OH group in the straight line structure comes at the right hand side, in this Haworth structure, it will always come at the down. Then it is called as alpha D glucopyranose. So first write this, that is alpha D glucopyranose. OH groups, first mention all the OH groups. OH on the first carbon atom is down, then second down, third up, fourth down, and for fifth there is no OH but it is with CH2OH. So it will be always with up. Now remaining valency of carbon is satisfied by hydrogen. Now the next one, beta D glucopyranose. The same structure is there. You can observe the structure. Only thing it differs at the first carbon atom. And the first carbon atom is called as anomeric carbon atom. So here OH group comes up and H group comes down. Now in these two structures, no need to show this thick line which is shown in hexagonal ring. Okay, you can show this simple line also. These type of structures are asked for 2 marks. One structure for 2 marks, remember. And in this, how the 2 marks are given? That is for each and every correct position of hydrogen and hydroxyl group. So please don't do any mistake in writing the structures. Keep the practice of writing the structures. In beta D glucopyranose also CH2OH comes at the top. Always CH2OH comes above the plane. Now here the detailed information is given. The 6-membered cyclic structure of glucose is called pyranose structure in analogy with pyran, that is the basic compound, organic compound with 1 oxygen and 5 carbon atoms. You can see here in this structure. This was established by R.D. Haworth. Hence, it is called as Haworth structure. So, refer page number 408 in textbook. I hope you understood about the glucose. Now, let us study one more compound, that is fructose. Fructose is having the formula C6H12O6. Now you may see both glucose and fructose are having the same formula. Then what is the difference? The difference is in their structure. What is fructose? The fructose is nothing but fruit sugar because it occurs in fruits. It contains 6 carbon atoms and ketonic functional group, that is C double bond O, and it is ketohexose. Hexose means 6 carbon atoms. It also belongs to D series, that is D we are writing. It is levorotatory, that is we are writing minus sign in the bracket, not the plus sign. So what is levorotatory? It is rotating the plane polarized light towards the left hand side. Hence it is called as levorotatory. So it is written as D dash minus in the bracket fructose, that is D minus fructose. Now left hand side, open chain structure of fructose is shown, which is also called as Fischer structure of fructose. Just see the structure of fructose. This also consists of 6 carbon atoms, 1, 2, 3, 4, 5, 6. First carbon atom, that is CH2OH. Then second carbon atom, that is CO, because CO, this functional group, is having the two attachments, means the two carbon atoms are linked to that. So third carbon atom is CHOH. Again you can observe here the OH group on the third carbon atom is on the left hand side, similar to that of glucose. Fourth OH is on right hand side, fifth OH is on right hand side, sixth is right hand side, even the first is on right hand side. So again this also, fructose also consists of 5 OH groups, straight chain of 6 carbon atoms, but the only difference is it consists of ketonic functional group. Now from this we are going to see how the structure can be given. Here evidences are not shown in your syllabus. Only the Haworth structures are shown. So how this Haworth structure is formed or cyclic structure is formed? In first blue color diagram, blue color structure is given as cyclic structure or it is known as cyclic structure, and the down is Haworth structure. As a ketohexose, fructose forms a 5-membered ring when the hydroxyl group on C5 reacts with carbonyl group on C2. In glucose, we have observed that the OH group on C5 reacts with carbonyl group of first carbon atom, that is aldehyde. But here, as carbonyl group is present in carbonyl group is present at second carbon atom, C5, that is OH group on C5 reacts with C2, that is second carbon atom, and forms 5-membered ring called as furan. So here furan basic structure is shown, which is 5-membered ring. Total 1, 2, 3, 4. 5 carbon atom. One of the carbon atom is replaced with oxygen. Now the cyclic structure, just see here the middle structure, how the OH group is linked to the CO, that is carbonyl group, and it forms the glycosidic linkage. Now here, where is CH2OH? CH2OH can be shifted towards right hand side or can be shifted towards left hand side. Now how to identify which is alpha and which is beta in this structure? Whenever OH group on the second carbon atom is on the right hand side, then this type of structure is called as alpha D fructofuranose. So this OH group which is at the right hand side, it comes down in this structure. If OH group is on left hand side, then it is called as beta D fructofuranose. So in exam, only the Haworth structures will be asked, not the cyclic structure will be asked. I hope you can understand the structure. Again the same method we have to do, that is first draw this basic structure. This basic structure you have to draw. In that no need to show the double bonds. Draw the vertical lines at each carbon atom. The first carbon atom in this is taken as CH2OH. Then second carbon atom is attached with OH. If OH is attached on the downside of the pentagonal ring, then it is called as alpha D. And if the OH group is attached on the top or on the above the plane, then it is called as beta D. This is first carbon atom in this. Then second carbon is attached to OH. and second and fifth are linked with O. In this structure also, second and fifth are linked with O. Third carbon atom, OH, is always on the up. That is, OH is on the top, H is down. Fourth, OH is down. And fifth one, H is down. And sixth one, because fifth is linked with O, sixth is CH2OH. So in this structure also, CH2OH is on the top. So CH2OH is also on the top. This is how the Haworth structures can be drawn. Remember students, fructose structure when you are drawing with as Haworth structure, always 5-membered ring is considered or 5-membered ring is drawn, whereas in glucose it should be 6-membered ring. I hope you understood the structures of glucose and fructose. The chemical evidences or the chemical proof are required only for glucose structures, not given for fructose. If any queries are there, you can call me or you can write your question on WhatsApp group. Thank you. I hope everybody is safe. Take care of yourself. Thank you once again. The further part we will see in next class.